The 8255 is a programmable parallel I/O device. It can be programmed to transfer data under various conditions from simple I/O to interrupt I/O. It's a flexible device that can be used to work with almost any kind of microprocessor. It has 40 pins as shown in the figure, with 24 pins dedicated to I/O ports. There are 3 of them, each 8-bit, port A, port B and port C. So the pins are PA7 to PA0 is port A, PB7 to PB0 is port B, PC7 to PC0 is port C, and then you have D7 to D0, which is the bidirectional data bus that connects to the microprocessor. Other than that, we have reset, chip select, read, write, and VCC and ground, and 2 address bits to address the 3 I/O ports. That's address bits A0 and A1. Before going into the architectural details of the 8255A programmable peripheral interface, let's take a look at what's meant by parallel data transfer and what are its requirements. This shows the 4 different methods of doing parallel data transfer between a microprocessor and an I/O device. The microprocessor and the I/O device are running at different clock speeds. The microprocessor is running at a much faster clock than the I/O device. So if you look at the various methods, there is the first method, which is called the simple output method, where data is put out by the device or the microprocessor, and it leaves the data there on the bus for some time, after which he assumes that the receiver has obtained the data and goes and changes the data signal. But we are not really sure whether the receiver has managed to store the data in his buffer. The second method is called the simple strobed I/O method, where we use an additional signal called a strobe, which is actually active low, so it is strobe bar, as a valid signal for the data bus. So once the data bus values have stabilized, the sender would pull strobe low, indicating that there is valid data on the bus, and after some time it will release the strobe back to its original value, and within this time period the receiver should get the data. Then there is the next method, which is called a single handshake I/O method, where before the data is transferred, we go through a handshake between a strobe and an acknowledgement signal, and then the data is transferred. So the operation begins with the strobe being pulled low, and the falling edge of strobe is used to latch the data into the data buffer. Once that's done, the acknowledgement goes high, and after some time the strobe is taken away and the acknowledgement also is released, so that we can go to the next data transfer. An even more stricter method is the double handshake I/O method, where again the handshake signals are put before the data transfer happens. So we have a strobe going low from the transmit side, which causes the receiver to acknowledge that it has seen the strobe, and it puts the data on the bus, after which the strobe is taken away, and that causes the acknowledgement to go low. As shown in the previous slide, the 8255A is a 40-pin IC. There are 24 pins dedicated for input-output ports, which are 3 8-bit ports A, B, and C. And port C can also be used as 8-bit input or output, or can be used as two 4-bit ports. It can also be used to produce handshake signals for ports A and B. So there are three modes of operation: mode 0, mode 1, and mode 2, which are based on the port initialization using the mode word. The figure shows the block diagram of the 8255A peripheral IC. The connections to the right hand side are the connections to the I/O device, which are the three ports: port A, port B, and port C. The connections to the left hand side are the connections towards the microprocessor, which includes D0 to D7, the data bus to or from the microprocessor. You can read data onto it or write data into the chip and out of one of the three I/O ports. Read bar and write bar are the enable signals to choose read or write operation. Below it, A0 and A1 are the address bus to choose the destination. 00 means port A, 01 stands for port B, 10 for port C, and 11 to read or write the control register. To start using the chip, you have to program the control register to select the desired mode: mode 0, mode 1, or mode 2. The right hand side of the block diagram has the three ports. A and B are 8 bits, and 3 can be two 4-bit ports. There are separate sub-blocks which generate control signals for the port A, called group A control, and separate control signals for port B, called group B control. Group A includes port A as well as the upper part of port C, and group B includes port B as well as the lower part of port C. We also have a chip select used for addressing this chip: reset, power, and ground. This slide describes the functionality in mode 0 of the various ports. So mode 0 is used in a simple I/O mode without handshaking. So if ports A and B are in mode 0, port C can be used as an 8-bit port, or two 4-bit ports which can be individually set as input or output ports. So when used as output, port C can be individually set or reset using a special control word. This shows how mode 1 is arranged. In mode 1, port A and port B can be both used for handshake input-output operation. The port C signals provide the handshake lines for port A and port B. So the lines PC0, PC1, and PC2 are used for handshake for port B, and the lines PC3, PC4, and PC5 are used as handshake signals for port A in the input mode, and PC3, PC6, and PC7 are used as handshake signals for port A in the output mode. Remaining port C pins are used as input or output lines. The handshake signals are strobe, STB, input buffer full, IBF, or INTR, interrupt. Mode 1 supports handshaked I/O operation on ports A and B, which are 8 bits, and the handshake signals are generated from the bits in port C. So specific bits in port C are used for handshake signals for port A, and specific bits in port C are used for handshake signals for port B. The handshake signals are strobe bar, input buffer full, and INTR. That is STB bar, IBF, and INTR. INTE is an internal flip-flop which is used to enable or disable the generation of the INTR signal. So there are two INTE bits, and they are INTE for port A, INTE for port B, and they can be set and reset using the BSR mode. The output handshake signals are ACK bar and output buffer full bar and INTR, and again an INTE, which is the interrupt enable, that can be set or reset using BSR bits. The STB signal in the input mode will be coming from the peripheral IO device, and the input buffer full will be coming out of the peripheral IC chip, which is the 8255A. In mode 2, port A can be used as a bidirectional port which works with handshake data transfer. So the data can be input or output on port A. The lines of port C are used to generate the handshake signals. So PC3 through PC7 are used to generate the strobe, IBF and INTR for port A. And PC0 to PC2 can be used as input or output lines if port B is in mode 0. This shows the control word format for programming the ports in the IO mode. It's a 8-bit word with bit D7 set to 1 if we want to keep the ports in IO mode. If it is 0, then it is in BSR mode. D5 and D6 are used for the mode select for group A signals. And so the group A mode selection would be 00, puts it in mode 0, 01, selects mode 1, 1 and a don't care for mode 2. The next bit D4, is the port A direction, 1 for input and 0 for output. And D3 bit selects the port C upper half, which belongs to group A. So again 1 means input and 0 means output. The remaining signals are for the group B signals. So bits D2 are the group B mode selects, and group B can be 0, which is in mode 0, 1 implies mode 1. The port itself of group B, which is port B, can be programmed to be either in input mode if it is 1 and output mode if it is 0. Bit D0 of the control word is used to program the lower bits of port C which belong to group B in these modes. So 1 would make the lower bits in input mode, and 0 would make the lower bits of port C in output mode. BSR mode is the bit set or reset mode for the bits in port C alone. The control word for BSR mode is shown here. So the control word bit D7 decides if it is for the IO mode or for the BSR mode. In BSR mode, bit D7 is always 0 and it affects only the port C bits. Bits D4 to D6 are don't cares. Then the 3 bits starting from D1, that's D1, D2, D3, are used to select the 8 output lines in port C. So you can select individual lines by setting those bits. 000 would target port C bit 0, and 111 would be addressing port C bit 7. D 0th bit tells whether to set or reset the selected port C bit.